Okay, dear students, we will continue our chapter Atoms, Molecules and Radicals. In the last section, we discussed the formula of compound. Firstly, you should write the valency of each radical at the top of the symbol. Here, the A have valency Y and B have valency X. Then, cross the valencies for the two radicals and place the numbers at the lower side of the radical as a subscript. You can cross the valencies for the two radicals and place the numbers at the lower side of each radical as a subscript. Then, second, divide the valency of each radical by a common factor if any. In the case of a compound radical, for writing the symbols of the two radicals, write the positive radical to the left and the negative radical to the right. That you must remember that we should write the positive radical to the left and a negative radical to the right. Okay, the next A have valency 4 and B have valency 2. Then we cross the valencies of the two radicals and place the numbers 4 at the lower side of B and 2 at the lower side of A as a subscript, and then divide the valence of each radical by a common factor. Here common factor is 2, and we can divide by 2, we get AB2. There are some exceptions like H2O2, that is hydrogen peroxide, in which the numbers of subscript are not divided by a common factor. You will understand that reason for this in higher class, but here we need the formula of AB2. Here A is tetravalent, that means it have 4 valence electron in the outermost shell and they require 4 electron additional to complete the octet. So it combine with the other 4 electrons, that is 2 from B, 1 B and another 2 from another B. That is B is divalent. They require only 2 electrons to complete their octet, but A require 4 electrons to complete their octet. So in the AB2 form, the A is tetravalent and B is divalent. Tetravalent valence 4 valence electron needed, and divalent means 2 valence electron necessary for the completion of octet. Here the valency of hydrogen can be next formula of the molecule of elements. Here the valency of one hydrogen can be satisfied by another hydrogen atom to form the molecule H2. Similarly, in the case of chlorine, to form Cl2 and O2 and N2, etc. That is, the valency of an atom can be satisfied by an atom of the element. Valency of an atom can be satisfied by an atom of the element, then forms formula of molecule. Okay, atom of the same element. The valency of an atom can be satisfied by a valency of the same element, that is H can be satisfied by an atom of hydrogen itself. One important thing is that you should remember that noble gas element is considered to have 0 valency. What are noble gas? That are helium, neon, argon, etc. It does not combine with another atom. That's why they are monoatomic. Their valency is 0. They did not attain any chemical reaction. Okay, next a big topic is radical. It's very important. Dear students, some people like being alone and they are happy when they are living alone, but in some peoples they make friends and make groups and they going outside with the friends. Okay, in chemistry some atoms act in a group. They form a group of atoms of same or different elements combined chemically that behave as a single unit with a positive or negative charge. Such a group of atoms is known as radical. Now something like similar where we heard about it before. Yes, the definition of a compound. Actually the definition of a compound is a group of atoms of same or different elements combined chemically that behave as a single unit. Then what is the difference between compound and a radical? Well, in radical we can see that there is a positive or negative charge on the radical, but compound is neutral, there is no positive or negative charge. So let's see some radicals. Radicals are mainly classified into two. One is positive radical and another is negative radical. Okay, positive radical again classified into monovalent, divalent and trivalent. Similarly, negative radicals again classified into monovalent, divalent and trivalent. In the case of hydrogen H plus, one electron is deficient. In the case of Mg2 plus, 2 electron is deficient. And in the case of aluminum 3 plus, 3 electron is deficient. That means hydrogen require 1 electron to complete the octet, and magnesium require 2 electron to complete their octet, and aluminum requires 3 electron to complete their octet. Hydrogen, sodium, potassium, copper, ammonium, etc. are monovalent. They require 1 electron to complete their octet. Octet means the completion of 8 electrons in the outermost shell. And in the case of divalent, there are 2 electrons. Magnesium 2 plus, 2 electron is needed. Calcium 2 plus, 2 electron is needed for the completion of octet. And the zinc, copper and etc. are doing the same. In the case of trivalent, aluminum 3 plus, iron 3 plus, they require 3 electron to complete their octet. That's why they are monovalent, divalent, trivalent. They are classified as. In the case of negative ion, there is an extra electron. In the case of fluoride, we should remove 1 electron to complete their octet. That means F minus. In the case of oxygen, 2 electron is excess. In the case of PO4, 3 minus, 3 electron is excess. That is monovalent is fluoride, chloride, bromide, iodide, hydroxide, nitrate, hydrogen carbonate. All these elements have extra electron in the formation of negative radical. That's why they are called monovalent. In the case of divalent, 2 electron is excess, and in the case of trivalent, 3 electron is excess. Oxide, sulfate, peroxide, carbonate, sulfate, all are examples of divalent, and phosphate is example for trivalent. Okay. Mainly radicals are capable of independent existence, but they are generally formed compound. Compound of this kind are formed by the combination of oppositely charged radicals in such a manner that charges are neutralized by each other. For example, in our text, one CO calcium 2 plus radical will require only one CO3 2 minus radical to neutralize its charge. Neutralize means to minimize their charge. Ca2 plus charge is there, and we require 2 minus charge for the neutralization. 2 plus charge and 2 minus charge combined to form 0. Okay, that means 2 plus charge of Ca2 plus require 2 minus charge of CO3. So it to neutralize, and the compound is CaCO3. But the another example is magnesium. Magnesium 2 plus also require 2 minus charge to neutralize the compound. So Mg2 plus will require OH minus have only 1 minus charge. That's why 2 OH minus we taken into consideration. That means Mg2 plus require 2 OH minus to form MgOH twice. The formula of compound containing radical can also be written by transposing the valency and dividing them by a common factor. Okay. Here, and the formula of compound radicals are also be written under transposing the valency and dividing them by a common factor. In our textbook, they are given an example of compound Cu2 plus and CO3 minus, and in Cu2 plus and CO3 2 minus is CuCO3 and not Cu2CO3. We have divided the valency 2 by a common factor. That's why they are not exist as Cu2CO3 twice. That means we can divide by a common factor 2. We get CuCO3 as the compound. Okay.